Okay, so for this next one, I would rewrite that as 2x to the negative 7th. And then when we go to do the power rule, we're going to multiply the power down. So that'll be negative 14. And then this drops a degree. So you're going to subtract 1. So it'll become negative 8. And then when you rewrite that to fix the negative exponent, it'll be negative 14 over x to the 8th. I made up a few others that weren't necessarily on there. This one I went over in the notes. This is x to the 1/2. So you'd bring down the 1/2, it would drop to negative 1/2, and then you have to fix the negative exponent. But I think you will just be much better off if you just remember derivative of square root is 1/2 square root. I just think if you have that one in your back pocket, that'll just be so much easier than dealing with the fractions and all the negatives and everything. So I would just try to know that one. Now this one, I would rewrite that as x to the 6/7. It's going to follow the same idea as this. The fraction is just a little yuckier. So if we go to do the power rule, we're going to bring the 6/7 down. So that'll be out front. And then you have to subtract 1. So 6/7 minus 1, you'd really be doing 6/7 minus 7/7. So it would become negative 1/7. And then when you go to fix the negative exponent, we still have this fraction 6/7 out front, so that still stays. This is going to come down to the denominator, and it would be the 7th root of x. So it was the same principle as this one. The fraction was just a little bit nastier, but the math and the idea behind it is the same. So this one, if you have two functions multiplied together, this is the product rule. And so that is the first function, so that's the 2x minus 6, times the derivative of the second one, which is 1/2 square root, plus, and then we've got the second function, and then times the derivative of the first one. This first derivative would just be 2 for the 2x. The minus 6 is a constant, so that's going to drop out. Right, so it was first derivative of the second plus second derivative of the first. And if you swap the order of that, that's fine, because adding, it doesn't make a difference which way you add it. So personal preference. All right, this one is quotient rule. That is the denominator times derivative of the numerator, which would just be 3, minus the numerator times derivative of the denominator. Now, this would just be 1. So you don't even have to write it really if you don't want to. And then that is over the denominator squared. You cannot switch the order of these because it's subtraction, and you can't subtract the other direction. Now this one we did reduce. So let's see, if we distribute this 3, that'll be 3x plus 6. And here I'm going to kind of ignore this 1. I'm just going to distribute the negative sign. So it'll be minus 3x plus 5. And the denominator is not going to change. And then the 3 x's cancel, and we're just going to add the 6 and 5. So we get 11 over x plus 2 squared. Now I added a question to this just to go over tangent line equations, since that's what we did last time. For an equation of a tangent line, you need 2 things. You need a point and you need a slope. And our point of tangency is going to be at x equals 1. So my point is going to be 1 something. So we're going to plug 1 into the original function just to see what we get. So the numerator would be negative 2, and the denominator would be 3. So negative 2/3. And then the slope comes from the derivative, and we're again going to plug in 1. So this would be f prime of 1. So if we plug 1 into this, that'll be 3 squared, which would be 9, so 11/9. And once you have your point and your slope, you can just put it all together. It's y minus the y value, which in this case, those are going to cancel. So y plus 2/3 equals the slope and then x minus the x value. Again, that wasn't on what you just did. I just kind of added that as an extra example problem. And then the last rule was chain rule. That's if you have a composite function. So the outside function here is square root. The inside function is all of this stuff. And I usually just call that like the guts of the problem. That's all the inside part. So we're going to do derivative of square root first. It is still 1 over 2 square root. That hasn't changed. It's just that instead of just square root of x, it's all that stuff. So all of that stuff stays. And then we're going to chain on, which just means multiply on, the derivative of that stuff. So multiplying the 3 down, this would be 6x squared minus 9. And you know, in the multiple choice, this was written in the numerator, so it was, it looked like this.